Today we're going to review and work on graphing equations in point-slope form. If we remember point-slope form, we remember that we have y minus y1 equals m times x minus x1. So we're going to take an equation given in that form and we're going to graph it. There are two ways of doing this: leaving it in the form and then graphing, or solving it for slope-intercept and then graphing. So I'm going to give an example equation. Let's say we have y minus 5 equals 2 times x minus 3. First thing I'm going to do if I'm in this form is I'm going to pull off the individual point that's given to me and the slope, and then I can use that to graph. So the point that is given to me, the x value of that point is 3. So I'm going to use that point 3, comma, the y value is the y1 in this equation, which happens to be 5. So that's 3, comma, 5. That's my point. My slope is my m value, so my slope is 2. So m equals 2. Now I'm going to do a quick sketch of this graph. Just draw a line down and a line across. And I'm going to start with the point given, 3, 5. So that's 3 over 1, 2, 3, 4, 5. And I'm going to use my slope. My slope is 2, which is really 2 over 1. I really can't go up to and over 1. There's not enough space. So when I can't do that, remember, I make them both negative. That's negative 2 over negative 1. So that's down 2 over 1. Down 2 over 1. Down 2 over 1. I have enough points now to connect my line, and I always have to remember that I'm going to put arrows on the ends of it and try and fill out the graph. Point-slope form is as easy as finding the point, finding the slope, and then graphing. Let's take a look at another example. I'm going to use the equation y plus 3 equals 1/3 times x minus 4. I'm going to first pull off the point, and before that I'm going to put the equation above it or below it. So y minus y1 equals m times x minus x1. That's the general form of the equation. Now to pull off my point, I'm going to see that my x1 value is 4. So my point is 4, comma, my y1 value. Notice that this is a minus and this is a plus. So this is technically minus negative 3. So my y1 value now is negative 3, the opposite of plus. So I'm going to have negative 3 for my y value. And my slope then is 1/3.
And the Lighthouse Committee meeting is in the library conference room. Lighthouse Committee meeting in the library conference room. Library.
I'm going to sketch my graph. I have the point 4, negative 3. That's 1, 2, 3, 4. Negative 1, 2, 3. That's my point. Rise 1, run 3. So rise 1, run 1, 2, 3. Or if I can't do that, I can make them both negative. Down 1, 3 to the left. I have enough points now that I can connect my line. And I extend and draw arrows on the ends. One other way of doing this is I could take either one of these equations and solve it for slope-intercept. So if I were to start with this first equation and solve it for slope-intercept, I would say y minus 5, the same equation, equals 2 times x minus 3. I would distribute, and that's 2x minus 6 equals y minus 5. Then I would add 5 to both sides, which gives me y equals 2x and a minus 1. So here, using my normal form, y equals mx plus b, my b value would be negative 1, which is why I have this y-intercept here. And my slope, of course, would be 2, which is 2 over 1, up 2 over 1. up 2 over 1. Same process. If I took this second equation and I solved it, y plus 3 equals 1/3 times x minus 4. Notice that my y-intercept is not very pretty here. It's not perfect. So this is going to be a little off, but I'm still going to solve. So distribute, which would be 1/3 x and a minus 4/3 equals y plus 3. Then I subtract 3 from both sides. So y equals 1/3 x, and here this is a negative 1 1/3 minus 3 again is a negative 4 1/3. So notice when I go to do the y-intercept, because y equals mx plus b, negative 4 1/3 is down 1, 2, 3, 4, and partially a little bit more of another. That becomes very difficult when it's not pretty. Up 1 and over 3. So up 1 would be in between right here, and over 3 would stay there, 1, 2, and 3, which would be this point.